Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at areas of triangles. Hopefully this lesson won't be too difficult because really we're not introducing too much new maths to you. You might have actually seen this formula before at GCSE. Now hopefully you can work out the area of a right angled triangle already. And actually, not just a right angled triangle, you should be able to work out areas of triangles where you know their perpendicular height. The perpendicular height is the height of the triangle that goes from the base straight up to the highest point and meets the base at a perpendicular angle, a right angle. In this lesson, what we're going to do is have a look at how we can find the area of triangles using a different formula where we don't have to know the perpendicular height, but we do have some restrictions of when we can use this formula. So here I have a triangle, and we can see it's not a right angled triangle because none of these angles, and you can just kind of tell by looking at them. Maybe C would maybe look a little bit like a right angle, but it's not because it doesn't have the box there, okay? The C might look a little bit like a right angle, but actually none of these are a right angle. So we can't just use the base times the perpendicular height divided by 2. So what formula can we use? Well, we have to use this formula. I'll introduce it in a minute. We have to use it when we have a certain restriction on the triangle, or some certain things we have to have. So the formula is used when we have something with the something between them. When we have, and I'll write it in red, we have two sides. And when I say we have two sides, I mean we know the length of two sides. And those two sides with the angle between them. So a little bit like when we did the cosine rule, we had to have the same thing. For the cosine rule, we had to have two sides and the angle between them. For the sine rule, we had to have pairs. So we had to know the length of a side and its opposite angle. And then to maybe find the length of another side, we had to know its opposite angle and the side that we wanted to work out. We just needed to know its opposite side. Here, we've got similar restrictions. We need to know two sides and the angle between those two sides. So for example, if we were asked to work out the area of this triangle here, I don't have any measurements or anything on the triangle, so I wouldn't be able to. But what we would have to know is, and I'll do it in red, we would have to know maybe this angle here, then the length of that side and the length of that side, okay? This angle we'd have to know, and then the length of those two sides, because that fits the criteria. We need two sides. There's the two sides, and we need to know the size of the angle between them. There's the angle between them, okay? We could also take a different two sides and the angle between them. We'll do this in green. We could take this side, and we could take that side, and then we'd have to know the angle between them there. So we'd have to know that angle for us to be able to work out the area of the triangle, okay? And then the final pair that we could have, and I'll do it in yellow, we could have this side and that side, know the length of both of those, and then the size of that angle between them. And then all we have to do is just substitute into this area formula, and this is the formula. Half AB sine C. That's the area for a non-right angled triangle when you have two sides and the angle between them. So what I want to just highlight though is that the formula works for every triangle, but your side A and your side B and angle C may not actually be side A, side B and angle C. If we look on this triangle, I just showed you three examples. The first one was these two sides and the angle between them, and that actually works for this lettering of the formula because there's side A, there's side B, and then that is C, angle C. So we do a half side A multiplied by the side B sine of the angle between them, which is C. But of course, really, if we look at this yellow pair that we've got highlighted, it's exactly the same to do this. A half times B times C times sine A. And hopefully you can see why that's the same, because all we're doing is just kind of changing these letters. we have a side here, another side here, the side B and C, so we've just put those there. And then the angle between them, well, it's not angle B and it's not angle C, so it has to be angle A. You don't have to think about lettering in the formula. You can just think this side and this side and the angle between them and substitute them into the formula. And it says that under this box here. Just like the cosine rule, the letters in the formula are interchangeable, so you can change the letters around. All right, let's have a look at 3 examples then. Oh, actually, before we do that, let's look at the proof of the formula. The proof is actually very simple, and I wouldn't really say it's a proof, it's more just a little bit of working out. If we were to look at this triangle here, again, it's a similar triangle to the one we just had. It just looks a little bit different, it's shaped differently, but it's not a right-angled triangle, so that's why it's really useful to use the formula. So, first of all, if we think about the area of this triangle, we can do it with our basic knowledge of areas of triangles. Base times the perpendicular height divided by 2. Even though it's not right angle, we know it's perpendicular height because it meets the base at a right angle and it goes to the tallest point on the triangle. So this is our perpendicular height. And it says the area of triangle ABC is a half AH. That is just the formula, base times height divided by 2. This is the base, and I should really have labelled that on, sorry. This is side A, let me do that in red, that's side B, and that's side C. Hopefully you can see why, because they're opposite the labelled angles. So we've got a half times the base, which is A, times the perpendicular height, which is H. So that is just a different version of base times perpendicular height divided by 2. It's just the letters for this triangle. But we know we can use trigonometry on this part of the triangle. If I just, am I going to be able to highlight it? No, I don't think I am. Let me do it in blue. We can use trigonometry just on that bit of the triangle there. Let me remove the fill from that, that's better. We can use trigonometry there because it's a right angle triangle, because we know the perpendicular height intersects at a right angle here. And we can basically get an equation, if you like, with H the subject. You can do basic trigonometry on this triangle here to say H must be B times sine of the angle C. Okay, and if you're unsure where that's come from, just do basic trigonometry to work out this side here. You'll use the sine ratio and then just multiply both sides by B to get H is equal to B sine C. And then all we can really do is just substitute that equation for H into the area. And then we just get this. You can see H has become B sine C from this equation here. And then the area is equal to a half times A times B sine C, which is the formula we just had up here. So the proof really is not much of a proof. It's just some simple steps to see where that formula comes from. Okay, now we will have a look at some examples. The first example is quite simple, so just pause and have a go. All you have to do is substitute into the formula. We're being asked to work out the area of the triangle. It's not a right angle triangle, and we also can't use our basic base times height divided by 2 because we don't know its perpendicular height. If we knew this height here, the length of that dashed line, then it's pretty simple. A half times the base times the length of that dashed line. But we don't know that, and it's not right angle, so we're going to have to use the formula that I'm introducing today. So, pause and have a go. Press play when you're ready. Maybe label these sides B, those angles, sorry, B and C. I missed that off. But you don't really need to think about it in terms of label sides. You've got 2 sides and you've got the angle between them, so just substitute into the formula. And then use your calculator to help you calculate. So pause and have a go, press play, and then we'll work through the answer. The first thing I would do is, without me telling you to do this, recognise the formula that you're going to use. Now, I've told you it's the formula for this lesson, but hopefully in an exam, if you've got a question like this at the start maybe, you should know really the formula that you're going to use, because we've not got a right angle and we've not got its perpendicular height. So let me write down the area formula. The area is half AB sine of C. And I like to put brackets around C, and it's a capital C because it's an angle. Now, A, B and the capital C don't match up on our triangle, but don't worry about that. Don't think about it too much as the formula in terms of lettering. Just think it's the two sides and the angle between them. And we have that. We have this side here, we have this side here, and we have the size of the angle between them. And so it's just pretty simple. Let's just substitute. So we will get this. We will get a half times, and I'm just going to use brackets here, one of the sides, which will go with 6.9, times the other side, 4.2, and then times sine of the angle between them, which is 75 degrees. And then just put that into your calculator. That's how simple this is. Now, I'm going to take this from the book, because that's where I got the example from. Let me have a look. So pretty simple. When we do that to three significant figures, this is what you get. Let me just see if I put this into my calculator though. What do I actually get straight off the screen? I get this. I get 13.99626, and that carries on. And then we've not really been specified whether we're giving it to two decimal places, three significant figures. If you don't have a specification, then I would definitely do three significant figures throughout the whole of your A-level. So three significant figures is this. It is 14.0. And of course it's an area, and we know the length of the sides, the unit for those was centimetres, and so the area is going to be centimetres squared. And just write 3SF for three significant figures. That's the area of the triangle. So for this topic really, or this formula, you can just get easy questions like that. But they do get a little bit trickier or a little bit more thinking involved. But because we're just dealing with that formula, you're going to start this question again thinking about the formula. It says here, find the value of x, given that the area of the triangle ABC is 12 root 3 centimetres squared. So we're given the area this time, so we know what the formula must be equal to. When we do the substitution into our formula, we know that the area is 12 root 3 centimetres squared. We're wanting to find the value of x, so that's our main goal for this question. So think, how are we going to get there? We have a triangle, we have the area of that triangle, and we have two lengths, and we actually have the numerical lengths, and we know the angle between them in terms of x. It is just x. So think what you can do, substitute into the formula and do some manipulation, some algebra, and hopefully you'll work out the value of x. So pause and have a go, press play, and then we'll work through the answer. Alright, just like we started the other question, I'm just going to write down the formula. So the area is equal to this, and it's the formula we're using because it's not a right angled triangle and we don't know its perpendicular height. So it's half AB sine of angle C, and maybe let's make that more of a capital. Again, the lettering might not be correct, but the lettering is just interchangeable. Don't think about it in terms of letters, just think we've got those two sides and the angle between them. So that's the area, but we actually know for this question what the area is. We know it's 12 root 3, and it's centimetres squared, but let's just ignore units for the minute. The area is 12 root 3. So in grey, I'm just going to write that that is equal to 12 root 3 for this triangle. Now let's think about the triangle and the lengths that we have. We have 8 centimetres, we have 6 centimetres, and we know that the angle between them is x. So let's substitute in, okay? Substitute is what we want to do. And we get this, we get a half multiplied by, well, one of the sides is 6, the other side is 8, and the angle between them, sine of x. This here is what we would compute to work out the area. If we knew the angle between them, and that's what we're trying to find, but if we knew it, then computing that would give us the area of the triangle, which we know is 12 root 3. So I'm just going to get rid of that equals and put the equals here, because we know that that must be equal to 12 root 3. Hopefully that makes sense there. Now all we have to do is just compute the value of x from that equation. So let's do some manipulation here. Well, a half times 6 times 8, that's just the same as 6 times 4, which of course is 24. And then we have 24 times sine x is equal to 12 root 3. Now I'm just going to put a little arrow there. This arrow, now we're doing kind of more complicated calculations and working out, this just means implies. And it's nice to put a little arrow as you work down your maths working, okay? It shows the examiner, this is what I've done, and on the next line this kind of implies this, and of course this implies this here, because all I've done is just calculated those numbers at the front, okay? And then we'll put another arrow because I'm just going to divide both sides by 24 because we're trying to find the value of x. So I want sine x on its own, and that's going to be 12 root 3 over 24, which hopefully we can work out is root 3 over 2. When we do that, this is what we get, okay? I'm just going to check this actually. So we have a half times 6 times 8, that's correct. And then 12 divided by 24 with root 3, yes, root 3 over 2. So then all we need to do is we just need to take the inverse sine of both sides. We want x on its own. At the minute, we've got sine x. So just like we divided by 24 to get sine x on its own, now we want x on its own, so we're going to take the inverse sine of both sides. And hopefully you remember that from trigonometry. So sine to the -1 is how we write it, but we don't say it like that. It's not a power, it's just the notation for inverse. So inverse sine of whatever is on the right hand side here, root 3 over 2. And when we put that into our calculator, this is what we get. Inverse sine of root 3 over 2 gives me 60, and I'm just checking this in my calculator. Yes, that is correct. So x is equal to 60 degrees. Check on your calculator that you've got a D symbol at the top. You should have a letter D to tell you you're in degrees. You don't want an R there. Radians we'll get onto later in the course. So that is our value for x. Now you don't really have to give a unit here because x, it is an angle, but we're just wanting to find the value of it. If we're thinking about it in angles, it's degrees, but I would just be careful and be safe and put a little degree symbol on there. So that is the angle that goes in the angle there, okay? It's the angle between this side and this side. And so if we were to basically substitute this x into this formula now, it would give us 12 root 3 as the area of the triangle. And we know that's correct because that's what we were told there. Okay, final example for this video is a little bit different, and we don't have the triangle drawn for us, we just have lots of information. We've gone from one example, which is just work out the area of this triangle. Then we've gone for another one, and we've included a little bit of algebra in there. We've had algebra in an angle, but it's still quite basic maths, just substitute into the formula and can you do algebra manipulation. Here, it's a little bit different because we have a triangle ABC, and AB is x centimetres, AC is 5 plus x centimetres, and then angle BAC, let me put a little hat there, angle BAC is 150 degrees. And we know that the area of the triangle is 3 3/4 centimetres squared. Part A says show that x satisfies the equation x squared plus 5x minus 15 is equal to 0. So really we've just been given some information. We know two sides, we know an angle, and we know the area. And then it's saying show that this quadratic is satisfied. So quite a big step up here. And then part B says calculate the value of x to 3 significant figures. So draw a triangle, have a go, just think about the formula, think about what you can do with that formula. Draw a triangle to help you, press pause, have a go, and then when you're ready for the answer, press play and we'll work through it. Just have a go at part A. Okay, part A, let's see what we can do. So under this box, I've actually started off part A, and really, I have just drawn a triangle. You have to get your triangle looking correct. We've not been given a triangle, so we need to use our drawing skills to draw one, basically. But be careful here, because this is 150 degrees, this angle, so it has to look right on your triangle. If I was to draw a triangle like that, where does the angle of 150 degrees go? Clearly not here because it doesn't look right, okay? It has to go like that for this angle to kind of look like 150 degrees. Maybe it's a little bit more, but it's just a sketch, okay? All right, so we're given that the area of triangle ABC is 3 3/4, and we want to show that x satisfies this equation here. So somehow we need to end with this equation. It's a show that question, so definitely don't start with this equation. You want to do maths from the information that you have to finish with this, because it's show that, okay? Whenever you have a show that question, do the maths and then show what you're trying to, well, what the question is asking you to show. So the only really piece of information in this video is this formula. So that's all we're going to use. We know the area, so it's a little bit like the other example. We can say that this must be equal to 3 3/4, which is 15/4. That is an improper fraction, I think, or sorry, a mixed number fraction. This is an improper fraction. 4 times 3 is 12, add the 3 is the number on top, so 15/4. So that's what that's equal to there. And then all we really need to do is we can just kind of use this information, or the information down here as well on the drawing, to just substitute into this formula. Again, the sides don't add up, A and B. This is side A and that's side B. Here we have side C and side B, but it doesn't matter. We have a side and another side and the angle between them, so just substitute that into the formula. So this is what we have here. I'll do my little arrow and I'm going to have a half times one of the sides, that's just the first one there, 5 plus x, times b, which is just another side, x, times sine of the angle between them, which is sine c, and it doesn't really matter which angle it is. It can't be that one or can't be that one because we know the two sides between them. It's actually angle A, but that doesn't matter, just substitute in the angle between them of 150 degrees. That's what the area would be if we were to calculate that. If we knew the value of x and we calculated that, it would give us the area of the triangle, because that's what the formula is. We've just substituted in. But we know what the area is. We know it's 15/4, or we know it's 3 3/4. So 15/4 is a nicer way to put that. So we can set that equal to 15/4. And now all we need to do is we just need to do some manipulation, just calculations to find the value of x. Sine of 150 is a numerical value, and if you remember it, that's fine. If you have to put it in your calculator, that's okay as well. Sine of 150 degrees is actually half, so we can replace that with half and then multiply it out the front to give me a quarter. So that's a quarter. 5 plus x times x is equal to 15/4. I've just replaced sine of 150 with a half and then put it out the front here to multiply those out to give me a quarter. We can then multiply both sides by 4, and that will just give me 1 at the front, so 5 plus x times x is equal to 15. And then I can just expand the brackets and I can take the 15 across to the other side. So we'll have 5x plus x squared is equal to 15. And that can tell me then that x squared plus 5x, writing it the other way around, minus 15 is equal to 0. And that is what we needed to prove. So we've done a nice proof, if you like. We've started with the information given in the question, not what we're trying to show, just the information here. We've started with that, we've done some maths, we've used the formula, we set it equal to the area that we're given, done some maths and some manipulation to get to the quadratic formula that we needed to show, or the quadratic expression, okay? And that is it. That's your answer for part A. So hopefully that's not too tricky. Even though we are using the area formula, we're not being asked to find the area. We can do quite a lot with that formula. And then part B, all we really have to do is just solve this quadratic. Part B said calculate the value of x. We know what the value of x is, or we know an expression for x, and it's this quadratic here. So all we have to do is just solve that quadratic, and we've done tons of that at GCSE and in previous lessons, So just solve it in a sensible way. Use the formula or use your calculator if you have a Class Whiz calculator or a calculator like that. You can solve it on there, and you get two values for x because it doesn't factorise nicely, and well, it's a quadratic, so you're going to get two values, but it doesn't factorise nicely, so you get a surd in it. And if you use the formula, then you would do some steps and you would get that at the final step. You'd get -5 plus or minus the square root of 85 divided by 2. And that is your value for x. There's two values there, so hopefully it said, oh, that should have said values. There we go. So that is example 3.